Quadratic functions and the discriminant, and this is a bit of a roundup. We've mentioned a lot of these things before, but now we're in a position to talk about them in a formal way. So we have the general quadratic function, y equals ax squared plus bx plus c, where we know that a, b, and c are just numbers in any particular situation. If a is greater than 0, i.e. the number in front of x squared, known as the coefficient of x squared, if that's positive, then the curve is this way up. We call it happy as a colloquial term, but the correct name for this is concave up. It's not difficult to remember because it's U-shaped. Concave up is U-shaped. If the coefficient of x squared is negative, so if we have a is less than 0, then it's a sad curve, which is concave down. Now the next three things I'm going to draw all for a greater than 0, but the same situation occurs when a is less than 0 as well. So this situation here has a curve which cuts the x-axis twice. In other words, the quadratic equation ax squared plus bx plus c equals 0 would have two distinct real roots. And we know that that situation corresponds to the discriminant being positive. Here we have a situation where we just have the one root. That corresponds to the discriminant being equal to 0. Remember, it's one root, or think about it as two coincident roots, two roots which are at the same point. And then finally, if it doesn't cut the x-axis at all, that corresponds to the discriminant being negative. Remember where this b squared minus 4ac occurs in the formula, you can't take the square root of a negative. I've drawn them all for a is greater than 0. If it was a was less than 0, I'll just do this first one as an example. It would be this way up, and it would still have the two roots. So for this one here, we'd have a is less than 0, but it would still be the case that b squared minus 4ac is greater than 0, so that it has two distinct roots.